Welcome to my video series where I will discuss electrophilic addition to alkenes. And this is going to take quite a bit to discuss, so I broke it up into several parts. To begin here, I'm going to go over a brief overview of what will be discussed in each of those parts. So when we talk about electrophilic addition to alkenes, we first want to look at the mechanism. And there's two general mechanisms to follow. One in which we go through a carbocation intermediate, and the other in which we go through a ring intermediate. With the carbocation, we have to pay attention to Markov-Nikov and possible rearrangement possibilities, where with the ring intermediate, there is no rearrangement, and there's really only one scenario that involves the Markov-Nikov, anti-Markov-Nikov sort of scenarios. Um, After that, we'll talk about the addition types a little bit, and actually we'll kind of discuss that a little bit more throughout the process of these reactions, but that is a syn and anti-addition. Basically, when you add to a double bond, both of the things being added can add to the same face or side of the double bond, or one can add one way, the other the opposite. So you can essentially get, if you think of stereochemistry, two dashes, you could get two wedges, or you can get one a dash and one a wedge. And again, explaining how that relates to a syn and anti-addition. And last, I'm going to go through some general examples of various types of addition processes and their names, like hydrohalogenation, adding a hydrogen and a halogen. Essentially, X is going to be a generic symbol for halogens. Technically, we can also think of X as being any nucleophile or any conjugate um, base sort of piece, but for the most part, when you see X, it's going to be a halogen. So in the next video, part 2, we will move into the mechanism for carbocation formation process.